In the previous video, we talked about what it would mean to estimate a parameter given sample information. Now we're going to use that idea and try to talk about point estimates and confidence intervals, specifically for trying to find population proportion. So let's talk about an example here. Let's say we want to know the percentage of the population that are Democrat. Let's say we want to figure that out. What percentage of people are going to vote for Democratic candidate for whatever election is you're interested in? Obviously, we could ask every single person in the country, figure that out, and go based on that. That's way too time intensive here. So instead, we ask, and I'm going to use 100 just because it's a nice easy number here. We ask 100 random people and find 45 will vote Democrat. Okay, so that means that for my sample, my p-hat value then is 45 out of 100, or 45%. So that means in the sample I have, 45% are Democrat. And that's all the information I have right now. All I know is I took one sample, 100 people, and I got 45 said yes. And just from this information, I have to pick a single number of which I believe will be the true value for the population. Well, the thing is I really don't have any choice. I only have one number here. I'm just going to say that I believe the true population is going to be 45%. Now, of course, I'm probably not going to be perfectly correct there, but we would usually imagine that samples that are taken randomly should be fairly representative of the population, and so it's probably not too far away from 45%. So anytime you want a point estimate, so the best point estimate for population proportion, which is P, will be the sample proportion, which is p-hat. So anytime you have to try to make a guess as to the value of your P, your population proportion, and all you have is a single data point, a single sample, you might as well just use the sample value proportion. That's the only number we really can even possibly guess. So that's our point estimate. Now we need to find the confidence interval. And to do the confidence interval, we need a margin of error. Now, I'm going to give you a formula for this and show you kind of how you would solve it by hand. But then we're also going to show you how to do it in the calculator later on. And the idea was, I said that, our sample was 45%. And we expect if the sample was taken randomly, we probably aren't off too far from that. So what we want to do is we want to say, well, how far off might we be if we're taking samples from a given population? And in fact, in a previous part of this class, we looked at the example of how far off would you be if you take samples from a given population, and we learned what the mean and the standard deviation was. The standard deviation for talking about sample proportion was the square root of P times 1 minus P over N. So you guys may or may not remember that. That was the formula for the standard deviation of p-hat. So the idea was if you took a bunch of samples and you calculated the sample proportion for each one of them and you looked at the standard deviation of all those possibilities, that was the formula we got. And we know from normal distribution and the empirical rule that if you go plus or minus 1 standard deviation, then the end result would be 68%, right? So if I decided to go plus or minus 1 there, then I would have a 68% confidence interval. But maybe I don't want 68%. Maybe I want to do plus or minus 2 standard deviations. And we know from the empirical rule, if you do plus or minus 2 standard deviations, then you would get a 95% confidence interval. Or what if I don't want that? What if I want to do plus or minus 3 standard deviations? Again, by the empirical rule, I would say, well, okay, that means I can have 99.7% there. So that means this is a 99.7% confidence interval. But what if I want something else? What if I want a 90% confidence interval? What if I want a 70% confidence interval? What if I want 85% confidence interval? So what we do is we put this thing here, and the notation in your book is Z alpha over 2. And let me just tell you, this is just the value of Z that will give a confidence level of 1 minus alpha %. Now that's kind of weird here, but let's say like your alpha is 0.1, then 1 minus alpha is 0.9, so that would be then giving you a 90% confidence level. And really, there's a table where you can look up each one of those things. You can say, this is what confidence interval I want. This is what Z number I want to use. For example, if you want a 95% confidence interval, now I actually said by the empirical rule that means you're going to use 2 there, but if you want to be a little more accurate, according to our table, it's going to be 1.96 here. That's the more accurate one from the table. And say, okay, what if I want to do something other than that? What if I want to say have a 90% confidence interval? Then what value do I want to have there? And if I look up on our table here, that's going to be a 1.645. Now again, these numbers I'm just pulling straight off of the table that we will look at later. And as I said, I'm also going to show you a video how to just do this in your calculator in 1 step, so you don't need these numbers. But this is the type of thing you would have. So once you have your Z alpha over 2 from your table, you have your numbers here for the standard deviation part, you plug them all in, you get your margin of error, you get your answer. There is one problem here that I want to point out, that I do make a little bit of a big deal about this. Let me circle this part and kind of go over here to the side. The formula is the square root of P, 1 minus P over N. That's the formula we had from a previous section. That's the formula that I'm writing down there right now. And there's something incredibly wrong with that formula, and that is that it's impossible for us to use. Because if you look at it, it says the square root of P times 1 minus P over N. But P by itself, that is the population proportion. And the whole point of this section is we are trying to estimate what P is, what the population proportion is. So it is literally impossible for you to tell me the value of that because we don't know what P is. We're trying to guess what P is. So really what we're going to do is we're going to say, okay, I know we can't do this, but we're going to hope that it's a good enough estimate to use the sample version there. So we're going to have the hats there, the sample proportion, and that's what we're really going to plug into our formula. So let's actually do an example here. It says we have N equals 100 people. We found 53 that had dark hair. I want to find the point estimate and the 95% confidence interval for the population proportion of individuals with dark hair. So if we say, okay, we know what our N is, we know our X, so my P hat is X over N. 53 over 100, that is 0.53. And that is my point estimate. If I had to guess a single number for the percentage of people that have dark hair, that would be 0.53 or 53%. Now to find the confidence interval, I need to find the margin of error. Margin of error. And we have the formula for that right up here. So we have to use our z-value, and we have our z-value for 90% confidence is 1.645. And then we're going to do the square root, and we're going to use the p hat instead of the real p, because we don't know the real p. 0.53 times 1 minus 0.53 over 100. And then we have to go ahead and get our calculator out for that. So I'm going to 0.53 times 0.47, that's what you get when you do 1 minus it, divided by 100, square root that, and then I'm going to multiply it by 1.645, and what I'm getting here is, if I round to the nearest percent, 0.08 or 0.082 if you want to go another decimal place. So that means my margin of error is 8 percentage points. So then my confidence interval, and then really my 90% confidence interval, is going to be 53% plus or minus 8%, which in terms of adding and subtracting, 53 minus 8 is 45, and 53 plus 8 is 61. So I would say I am 90% confident that the true percentage of people with dark hair is somewhere between 45% and 61%. And you can do it in decimal or percentage format there, I don't care. So this is how we can find our confidence interval using the formulas. As I said, I will show you a separate video where we do the same problem using the TI-84 calculator, and then we will see we get the same answer without having to do the separate little steps here. Now, there's one last thing in this section to talk about. What if this is before you have actually done your sample, and you say, okay, I want to take a sample and I want it to be fairly accurate. I want to determine how big of a sample I need to be as accurate as I want it to be. And you're going to have two formulas for this depending on the context. One formula is that your sample size needs to be at least 0.25 times z alpha over 2 over the error you want squared. And this just comes from taking the formula for the margin of error and essentially trying to solve for the error, solve for the n in that equation at least. And then again, you can just have this formula written down on the side on your note card. And then we have our n there. The other one is if you have a guess for what the value of p hat is going to be, then we use this formula right here, z alpha over 2 over e squared. So how am I going to do it for this problem? It says we are going to use the point estimate above. So we're going to use the 0.53. And want to see how large of a new sample should we take if we want a margin of error of only 2%. So you see, in the previous one, my margin of error was 8%. I'm going to say that that's too wide. I don't want to be within 8% of the right answer. I'd like to hopefully be within 2% of the right answer. So I use the bottom formula because we have our previous guess. Our previous guess is 0.53. I know my z alpha over 2 from before is the 1.645, and I'm dividing it by the error, which is 0.02, and then I'm squaring that. So let me go ahead and put this all in my calculator now. 1.645 divided by 0.02, and then square that answer. Then multiply that by 0.53, and then 1 minus 0.53 is 0.47. And what I'm getting here is n equals 1685.177 and so on. But keep in mind for sample size, you want it to be a whole number, right? You can't ask 0.177 people. So then I would say I need a sample of at least, so you always round up for these, 1686 people. So if I want my answer to be within 2 percentage points instead of 8, then I would go between, I need at least, almost 1,700 people to get to that answer. And so you have these formulas here, and you use them specifically when you're trying to see how big of a sample should I have to get this error level that I'm comfortable with. And this is the type of thing that the companies do when they're deciding to take a sample. They know how much error they want to have on their end results. They take a big enough sample, and then they base it off of that. So it's definitely something that is used out there by people that do surveys and polls. But all of this here is what we're going to do when we're trying to estimate the population proportion of whatever it is we're talking about.